In this tutorial, we shall try to learn how to manually solve a two-way ANOVA problem with replication. In this age of using software, manual solving has its own significance. Well, this is the problem we are going to solve today. A professor conducted an experiment to compare the relative effectiveness of three methods for learning algebra: study group method, computer aided method, and game simulation method. 30 students consisting of 15 males and 15 females were randomly assigned to three instructional groups, each containing 5 male and 5 female participants, and taught using the respective methods. After the instructional period, all participants completed a standardized algebra test. The following table presents their test scores. It is given in the form of a table. Column values show the marks obtained by students from three teaching methods. Male and female are divided into two major groups, each consisting of 5 subgroups, and are shown along the major rows. Based on the above data, you have to construct the ANOVA table to analyze the data. Test the effectiveness of the teaching methods. Test the impact of gender on algebra learning outcomes. Test for interaction effects between teaching methods and gender. In solving this problem, we are going to follow these steps. 1. Form hypothesis. 2. Calculation of SST, that is sum of square of total variation. 3. Calculation of sum of square of column variation. 4. Calculation of sum of square of row variation. 5. Calculation of sum of square of errors. 6. Calculation of sum of square of interaction. 7. Calculation of mean squares. 8. Calculation of F ratio. 9. ANOVA table. 10. Results. These are the major steps in solving this problem. The first step, forming hypothesis. Null hypothesis. There is no significant difference in mean test scores among the three teaching methods. Alternate hypothesis. There is a significant difference in the mean algebra test scores among the three teaching methods. Hypothesis 2. Null hypothesis. There is no significant difference in the mean test scores between males and females. Alternate hypothesis. There is a significant difference in the mean test scores between males and females. Hypothesis 3. Null hypothesis. There is no interaction between gender and teaching method in affecting algebra test scores. Alternate hypothesis. There is a significant interaction between gender and teaching method in affecting algebra test scores. The second step, calculation of sum of square of total variation. Let us begin with the calculation of correction factor, that is CF. For this, let us understand the table first. The table has three columns: study group, computer aided, and game simulation. Let us denote the number of columns as capital C. Capital C equal to 3. This column is horizontally divided between male and female. For analysis purpose, we shall treat 5 male rows as one major row and 5 female rows as one major row. Then there are two major rows. Let the capital R stands for number of major rows. Then capital R equal to 2. Let us use small c to denote the number of observations in one subcolumn. Then small c equal to 5. Let us use small r to denote the number of observations in one subgroup. then small r equal to 3. And finally, the capital N stands for the total number of observations. Then capital N equal to 30. With this understanding, we shall proceed to solve the problem. To calculate correction factor, we use the formula CF equal to sigma Tc whole squared by capital N. We shall move to calculate sigma Tc. Let us have a few additional rows to facilitate our calculations. Calculate the male sub-column totals, that is Tc1. They are 180, 149, 152. Then calculate the female sub-column totals, that is Tc2. They are 175, 126, 160. Calculate combined total, that is Tc, by adding Tc1 with Tc2. They are 180 plus 175, 355, 149 plus 126, 275, 152 plus 130, 282. Find the grand total, that is sigma Tc. It is 355 plus 275 plus 282, 912. We have sigma Tc, it is 912. Substitute the values in the formula. 912 squared by 30. Simplify. 8,31,744 divided by 30. Correction factor is 27,724.8. We shall turn to calculate SST now. The formula we are going to use to calculate SST equal to sigma x square minus correction factor. We have the value of correction factor, it is 27,724.8. Let us now calculate the value of sigma x square. We have already identified the values in the given table as x. Square them all. Its grand total is sigma x square. It is 28,942. Let us substitute the values in the formula and simplify. 28,942 minus 27,724.8. 1,117.2. SST is 1,217.2. We shall turn to calculate the sum of squares of column variation, that is SSC. For this, we need to calculate a few more values. Let us add two new rows to the bottom. The formula that we are going to use to calculate is SSC equal to sigma t square by small c times capital R minus CF. We have the value of CF. It is 27,724.8, and we know the value of small c and capital R. They are 5 and 2. But we have to find the value of Tc square. Square the Tc values. They are 1,26,025, 75,625, 79,524. Its grand total is 2,81,174. It is sigma Tc square. We know the values of small c and capital R. Substitute them in the formula and simplify. 2,81,174 divided by 5 times 2 minus 27,724.8. 2,81,174 divided by 10 minus 27,724.8. 28,117.4 minus 27,724.8. SSC equal to 392.6. We shall now calculate sum of squares of row variation. For this, the formula we have to use is SSR equal to sigma TR square divided by small c times small r minus CF. We have the value of CF, it is 27,724.8, small c it is 5, small r it is 3. We have to calculate the value of sigma TR squared. Let us open two new columns to the right. Name them as TR and TR squared. Find the total of the first major row values. It is so simple. Add all the sub-column totals, that is TC1 values. It is 180 plus 149 plus 152, 481. Place it in column TR. In the same way, find the total of the second major row values. It is 431. Square both the values. They are 2,31,361 and 1,85,761. Place them in the adjacent column. Add these two squared values. It is sigma TR squared. It is 4,17,122. We shall substitute the values in the formula. 4,17,122 divided by 5 times 3 minus 27,724.8. 4,17,122 divided by 15 minus 27,724.8. 27,808.1 minus 27,724.8. SSR equal to 83.3. Then it is time to estimate the sum of squares of error, that is SSE. To find SSE, use the formula SSE equal to sigma x square minus sigma t C12 square divided by small c. We have the value of sigma x square, it is 28,942. We have the value of small c also, it is 5. But we have to find the value for the term sigma t C12 square. For this, we have to square the subcolumn total values, that is TC1 and TC2 square. For want of space, let us create new table with the values of TC1 and TC2. Square the values now. TC1 square 32,400, 22,201, 23,104. TC2 square 30,625, 15,876, 16,900. Arrive at the grand total TC12 square 1,41,106. Substitute the values in the equation and simplify. We get SSE equal to 28,942 minus 1,41,106 by 5. 28,942 minus 28,221.2. SSC equal to 720.8. Calculation of SSI. Finally, let us calculate sum of squares of interaction, that is SSI. Its formula is so simple. It is SSI equal to SST minus SSC plus SSR plus SSE. We know the values of SST SSC, SSR and SSE. They are 1217.2, 392.6, 83.3, 720.8. Substituting these values and simplifying, we get SSI equal to 1217.2 minus 392.6 plus 83.3 plus 720.8. 1217.2 minus 1196.7 SSI 20.5. We have finished the calculation of all the sum of square variations. Now it is time to calculate the corresponding mean square variation values. For this, we need the corresponding degrees of freedom for the values SSC, SSR, SSI, SSE and SST. We shall find them one by one. Good. To find the mean squares of SSC, SSR, SSI and SSE by dividing with the respective degrees of freedom, we shall start with the estimation of their respective degrees of freedom. Degrees of freedom of SSC is capital C minus 1, where capital C is the number of major columns. It is 3. Degrees of freedom of SSC is 3 minus 1, 2. Degrees of freedom of SSR is capital R minus 1, where capital R is major number of rows. It is 2. Degrees of freedom of SSR is 2 minus 1, 1. Degrees of freedom of SSI is capital C minus 1 times capital R minus 1. Then degrees of freedom of SSI is 3 minus 1 times 2 minus 1, 2 times 1, 2. Degrees of freedom of SSE is capital N minus C times R, where capital N is total number of observations. It is 30. Degrees of freedom of SSI is 30 minus 3 times 2, 30 minus 6, 24. Degrees of freedom of SST is capital N minus 1, 30 minus 1, 29. Now we shall proceed to calculate the mean square values of SSC, SSR, SSI and SSE by dividing with the respective degrees of freedom. MSC equal to SSC minus degrees of freedom 392.6 by 2, 196.3. MSR equal to SSR by degrees of freedom equal to 83.6 divided by 1, 83.3. MSI equal to SSI divided by degrees of freedom equal to 20.5 divided by 2, 10.25. MSE equal to SSE divided by degrees of freedom equal to 720.8 divided by 24, 30.03. Well, next we have to find the F ratio of column, row and interaction by dividing MSC, MSR and MSI by MSE. We shall do it here. Column equal to MSC by MSE 196.3 divided by 30.03, 6.57. Rho equal to MSR divided by MSE equal to 83.3 divided by 30.03 equal to 2.77. Interaction equal to MSI divided by MSE equal to 10.25 divided by 30.03 equal to 0.34. Next, we shall construct the ANOVA table and populate the cells with values. In the ANOVA table, the critical values of F are missing. Without this, we cannot test the hypothesis. Okay, there is no mention about the significance level, so we shall use our discretion. We shall test the hypothesis at 5% level of significance. Use the F table that is constructed for 5% level of significance. For the mean square of column, we have to find the F value like this. Its numerator degrees of freedom is 2 and its denominator degrees of freedom is 24. Move 2 units along the top row and move 24 units down. Locate the F value. It is 3.40. Place it in the table. For the mean square of row, we have to find the F value like this. Its numerator degrees of freedom is 1 and its denominator degrees of freedom is 24. Move 1 units along the top row and move 24 units down. Locate the F value. It is 4.26. Place it in the table. Since the mean square of interaction has the same degrees of freedom as mean square of column, we shall use the F critical value 3.40 in this case also. Place it in the table. Finally, the results. We have come to the end part of our discussion. It's time to declare results. Hypothesis 1. There is no significant difference in the mean algebra test scores among the 3 teaching methods. Conclusion. Since the calculated F value 6.57 is greater than the table F value 3.40, the null hypothesis is rejected. Inference. There is enough statistical evidence to declare that all teaching methods are not equally efficient and at least one method is more efficient than the other two. Hypothesis 2. Null hypothesis. There is no significant difference in the mean algebra test scores between males and females. Conclusion. Since the calculated F value 2.77 is less than the table F value 4.26, the null hypothesis is accepted. Inference. There is enough statistical evidence to say that both male and female are equally efficient in learning. Hypothesis 3. Null hypothesis. There is no interaction between gender and teaching method in affecting algebra test scores. Conclusion. Since the calculated F value 0.34 is less than the table F value 3.40, the null hypothesis is accepted. Inference. There is enough statistical evidence to conclude there is no interaction between gender and teaching methods. Well, our discussion ends here. We shall meet again in the next video lesson.